Hello friends, welcome to the session. Continuation of classroom workbook based on buck regulator, boost regulator and buck boost regulator in chapter 7, that is DC to DC converter. Okay. I think in the last session I discussed up to question number 16, correct? Yes. Then we'll start with question number 17. Okay. See the question number 17 or the solution for this. Read the question. A buck converter has input voltage of 14 volts. Input voltage is 14 volts. Yes. And the average output voltage is 6 volts. Given is buck converter. And peak to peak output ripple voltage is 15 millivolts. Output voltage is nothing but a capacitor voltage also, because voltage across the capacitor is nothing but a output voltage. This is 15 millivolts. The switching frequency is 30 kHz. F equal to 30 kHz. Okay. If the peak to peak inductor current is limited to 0.6 ampere, delta IL equal to 0.6 ampere. Okay. Determine duty cycle, filter inductor, filter capacitor. We want to calculate what is the filter inductor, filter capacitor and duty cycle. Given is which converter? Buck converter. Buck converter means, what is the first question? We want to calculate duty cycle. What is V0 equal to dVdC? Okay. From this, what is the duty cycle equal to? V0 by Vdc. What is the average output voltage? 6 volts. What is the supply voltage? 14. Then how much duty cycle we can get? We simplify this, we can get 0.4285. This is the duty cycle we can get. This is the first question. What about B? You calculate filter inductor and filter capacitor. Then how to calculate filter inductor? To calculate filter inductor, can you define delta IL equal to D into 1 minus D into Vs by Fl. This formula you know. D into 1 minus D into Vs by Fl. Vs in the sense you take Vdc. Vdc by Fl. Peak to peak inductor ripple current is 0.6 ampere. Duty cycle is 0.4285. 1 minus 0.4285 into Vdc. Vdc is how much it is given? 14 volts. By frequency, switching frequency how much? 30 kHz into L. Now from this we calculate inductor. Filter inductance we can get 190.48 microhenry. We simplify this one, we get 190.48 microhenry. The calculations you do. Okay. Then you also calculate filter capacitor. Then to calculate, in the same question, you calculate filter capacitor. To calculate filter capacitor, you define delta Vc. Okay. Then how to calculate delta Vc? This you know the formula. D into 1 minus D into Vdc by 8 LC F square. 8 LC by F square. What the delta Vc is given? Peak to peak ripple voltage 15 millivolts. 15 into 10 to the power of minus 3. 0.4285. 1 minus 0.4285 into Vdc is how much? 14 volts. 8. L you calculated now 190.48 microhenry into 10 power minus 6. See what is the capacitance value you calculate. Frequency is how much? 30 kilohertz. 30 into 10 cube whole square. Then from this you calculate C, filter capacitor. Then we get 166.67 microfarad. By simplifying this, 166.67 microfarad. This here it is not a critical capacitance, it is not a critical inductance. It is asked you find the normal filter inductance and filter capacitance. Then we calculated filter inductance and filter capacitance. Clear? Concentrate. Quick. This is question number 17, A and B. See the question number 18. All of you read the question? Yes. A boost converter input voltage is 6 volts. The average output voltage is 18 volts. Or the input voltage of boost converter 6 volts. The average output voltage is how much? 18 volts. Okay. And the average load current is 0.4 ampere. The average load current is 0.4 ampere. This is a given data. The switching frequency is 20 kilohertz. The switching frequency is 20 kilohertz. 20 into 10 cube H. Okay. Then for inductance of 250 microhenry, capacitance of 420 microfarad. For inductance of 250 microhenry and capacitance of 420 microfarad. Okay. Then determine duty cycle, the ripple current of inductor. Then you also peak current of inductor, the ripple voltage of capacitor. First you want to find duty cycle. Given is which converter? Boost converter. That is boost regulator. Then what is D equal? What is V0 in the boost regulator? V0 equal to VDC by 1 minus D. Then 1 minus D equal to VDC by V0. What is VDC? 6 volts. What is V0? 18. Then what is D? You can get 2 by 3. You can get. The duty cycle equal to how much you can get? The value of duty cycle equal to 2 by 3. Thus how much percentage? 66.67% we can get. This is the first question. For the second one, it is asked you calculate the ripple current of inductor. Peak to peak ripple current of inductor. Can you tell what is the formula for delta IL in a boost converter? dVs by FL. Then what is duty cycle? 0.667 into Vs. Vs is nothing but a VDC. Sorry, VDC. VDC how much? 6 volts. Frequency, switching frequency 20 kilohertz. 20 into 10 cube. For the inductance is given 250 microhenry. 250 into 10 power minus 6. Then you calculate what the peak to peak inductor ripple current. By simplifying that we can get 0.79 ampere. You do this. Do the calculation. Okay, 0.79 ampere. What is the question number C? It is asked you find the peak current of inductor. What is the peak current of inductor? The peak current of inductor IL max equal to IL plus delta IL by 2. Then what is IL? It is a boost converter na. I0 by 1 minus D plus delta IL 0.79 by 2. What is I0 is given? I0 is given average load current. The average load current is 0.4 ampere. It is given as average load current is 0.4 ampere. Correct? See the question. Average output voltage is a boost converter. Sorry, this one na. Average load current is 0.4 ampere. 0.4 by 1 minus 0.667 plus 0.79 by 2. You simplify this one. What the peak inductor current we can get? This we can get 1.6 ampere. Peak value of inductor current. Then what is the peak to peak ripple voltage? Peak to peak capacitor voltage. Delta Vc equal to, what is the formula? Di naught by Fc. Di naught by Fc. Duty cycle, 0.667. I naught, 0.4 amperes. Frequency, 20 kilohertz. Capacitance, 420 microfarad. You substitute that by simplifying this, we can get 31.76 milliamps. Here, answer 19. Question number 19. Yes. A buck boost converter, the input is 14 volts and the duty cycle is 0.6. The switching frequency is 25 kHz. Input is VDC is 14 volts. Given is buck boost converter. The duty cycle is 0.6. The switching frequency is 25 kHz. 25 kHz. Okay. The inductance is 180 microhenry and the capacitance is 220 microfarad. If the average load current is 1.5 amperes, the average load current is 1.5 amperes. This is the given data. First one, the average output voltage is to calculate. Calculate average output voltage. Given is buck boost converter na dVdC by 1 minus d. This is we calculate average output voltage. V naught equal to duty cycle is how much it is given 0.6. 14 by 1 minus 0.6. Then V naught you calculate. By simplifying this V naught you can get 21 volts. Okay. 21 volts you can get. Then what is the question number B? In 19th question number B. The peak to peak capacitor ripple voltage. The peak to peak capacitor ripple voltage. Then you calculate delta Vc. What is the delta Vc formula? Di naught by Fc. D is duty cycle how much? 0.6. I naught is how much it is given? 1.5. Frequency how much? 25 kHz. Capacitance how much it is given? 220 microfarad into 10 power minus 6. Then peak to peak capacitor ripple voltage we can get 0.16 volts. We simplify this, we can get 0.16 volts. Okay. Then you also calculate peak to peak inductor ripple current. Peak to peak inductor ripple current. What is the delta IL formula? dVs by FL. That is dVdC by FL. Duty cycle is how much? 0.6. What is VDC? VDC is how much it is given? 14 volts. Frequency how much? 25 kHz. L is how much? It is given 180 microhenry. 180 into 10 power minus 6. We simplify this, we can get 1.87 ampere. 1.87 ampere. Okay. Then this is C. D is peak value of switch current. Peak value of switch current. What is the peak value of switch current in buck boost regulator or buck boost converter? Peak value of switch current is nothing but peak value of inductor current. Peak value of inductor current is how much? IL plus delta IL by 2. IL plus delta IL by 2. What is IL? You write I naught by 1 minus D. This formula you know. Plus delta IL by 2. How much I naught is given? 1.5 by 1 minus 0.6 plus delta IL we calculated now 1.87 by 2. Then by simplifying this, the peak value of switch current equal to 4.68 amperes we can get. That you do. Clear? Concentrate. Quick. Yes. See the question number 20. Read the question. A buck converter feeding a variable resistive load as shown in figure. This is question number 20. The switching frequency of switch S is 100 kHz and the duty ratio is 0.6. The output voltage V0 is 36 volts. Assume that all the components are ideal and that output is ripple free, that is continuous mode. The value of R in ohms that will make the inductor current is just continuous. Okay, this is the given circuit. Okay, and this is the diode. Inductance is given is 5 millihenry. The output voltage is 36 volts. This is the variable resistor. This is 60 volts it is given. This is a switch. This is a diode. What is regulator? S. Inductor is at load side na. That's why it is which regulator? Buck regulator. That is buck converter. Then question is asked to make the current is just to continue. Inductor current is just to continuous. Then you find the resistance. The value of inductance at which the current is just to continuous. That inductance is called critical inductance. We know this critical inductance LC equal to R into 1 minus D by 2F. This you take this inductance is the critical inductance. 5 into 10 power minus 3. Corresponding to this you want to find the resistance. Corresponding to this you want to find the resistance. R into 1 minus duty cycle is 0.6. 2 into what the frequency it is given. This which is operated frequency of 100 kHz. 100 kHz. 100 into 10 cube. Then how much you get you tell me. R into 0.4. R into 0.4 equal to this 10 power minus 3 10 cube. This is becomes cancel. Then what is 200 into 5. 200 into 5. Then what is the resistance equal to 200 into 5 by 0.4. Then how much you get? 2500 ohms you can get. This is a variable resistor. If you select this is varying this one, if you select 2500 ohms, the current through the inductor becomes just to continue. Understood? This is the inductance, this is the resistance which makes the current through the inductor is this. Because if you control the resistance, what the current through the inductor is also controlled. Understood? Okay, this is the resistance is required to make the just to continue. Okay, concentrate, quick. I already given the formulas for critical inductance in buck regulator, critical inductance in boost regulator, critical inductance in buck boost regulator. That also you try based on that critical inductance formulas also. This is the resistor. #21. Shall I read the question? For the circuit shown in figure, switch is operated at duty cycle of 0.6 and switching frequency of 10 kHz. and then calculate maximum inductor current, the value of L connected, critical value of inductance. Yes, this is the given circuit. This is the switch. Yes. You want L connected, and this is the capacitance. This, how much it is given? 40 ohm. And this voltage is given is 80 volts. And this is 100 volts. The switch is operated at duty cycle of 0.6. Then you calculate maximum inductor current, the value of maximum inductor current, the value of L connected, critical value of inductor. Listen, please. Here it is not mentioned that continuous mode or discontinuous mode, but to check the continuous or discontinuous mode, here data is available. This concept you concentrate. Generally, duty cycle is, supply voltage also, It is which regulator? Buck regulator. What is the buck regulator? V0 output voltage, V0 equal to dVdC. If you calculate duty cycle is given is 0.6. This is VDC is 100 volts. How much we can get? 60 volts. But in the problem, whatever the voltage is given, this is 80 volts. This is the voltage in continuous mode now. This is the output voltage in continuous mode. But given voltage is 80 volts. Given is 80 volts. Given V0 is 80 volts. But calculated V0 is 60 volts. 80 volts is greater than 60 volts now. This is V0 in continuous mode. This is greater than this we are getting means compulsory. That is the voltage under discontinuous mode. This is voltage under discontinuous mode. We are getting 80 volts means here 60 volts I am getting. This is the continuous mode output voltage. But in the given circuit, how much it is? 80 volts. That means you are getting greater than 60 volts means compulsory this circuit must be operate in which mode? Discontinuous mode. That's why this problem you want to solve in discontinuous mode. Okay. What the first question it is asked? You find the yes. Tell me. You find the maximum inductor current. You find the maximum value of inductor current. What is the maximum inductor current? How to calculate maximum inductor current? First, I want to calculate in a continuous mode. You know that what is V0 in a discontinuous mode. Therefore, it is operated in discontinuous mode. It is under discontinuous mode. Under discontinuous mode. Okay. Then what is V0 under discontinuous mode? dVdC by beta. What is V0 is given 80 volts. Duty cycle is 0.6. VDC 100. This is beta. Then how much beta we can get? We simplify this. Then we get beta equal to 0.75. Beta we can get 0.75. Okay. Then first one is you calculate maximum inductor current. We know that in a discontinuous mode means what are the wave shapes? I already given this waveform. Under discontinuous mode, before completing one time period, the current falls to 0. This is T. This is T. This is beta T. Again current will be started. Then this is what this current? IL max. This is IL max. IL max is nothing but a delta IL. IL max is nothing but a delta IL. That means you want to find, first question is you want to solve for IL maximum. Maximum inductor current is nothing but a delta IL. You calculate delta IL, that gives the maximum inductor current. Then how to calculate delta IL? Then how to calculate delta IL? Then to calculate delta IL, you go for what is the average? First, you tell me. What is the average current through the inductor? If you want to calculate average current through the inductor means, can you equate this one? Input power equal to output power. Input power equal to output power. Then what is input power? Input power. What is the input power? Input power is nothing but a VDC into IS is equal to output power is nothing but a V0 into I0. Okay. This is 80 volts. This is 40 ohms. Then what this current you tell me? This is 80 by 40. This is equal to 2 ampere. Yeah. This is I0 is 2 ampere. I0 is 2 ampere. Then shall we equate like this? VDC is how much we can? 100 into IS. This is equal to what is V0? V0 is 80 volts. I0 is how much? 2 ampere. Then from this, what is IS average we can get? Then we can get IS average equal to 1.6 ampere. This IS average. All this I am doing to calculate the delta L. We are getting IS average equal to 1 point. We know that if you draw the source current waveform, we are getting the source current waveform also like this now. The source current waveform. The source current waveform is nothing but a delta L. This also delta L. We know the source current waveform. Can you calculate what is the average source current? Average source current formula. Can you apply average source current? This is during which time? T on time. We are getting source current is during which time we can get? On time only. What is the average source current? IS average equal to, this is IS, half into this is during which time? T on time. T on time. T on is nothing but a dt into delta L by the total time period. In the total time period we are calculating average na by T. Understood? This is the source current waveform. From that source current waveform I am defining IS average. But IS average we calculated. What is IS average? 1.6 ampere. TT cancel. 1 by 2 into duty cycle is how much it is given? 0.6 into delta L. Now from this, what is the delta L we can get? Delta L equal to, we simplify this, how much we can get delta L equal to? You tell me. Then we get 5.3 ampere. 5.3 ampere. This is delta. But delta L is nothing but IL max. Therefore, IL max equal to delta L. This equal to how much we get? 5.3 ampere. This is the first question it is asked. Concept very simple. I want to calculate IL max. IL max is nothing but delta L. For that, first I am calculating average current to the switch. Average current to the switch during which time it appear? On time. During on time only switch is on. Then from that I am equating the average current to the switch. Then because it is a discontinuous mode, now it is started from 0. This is directly indicates the delta L. Delta L is nothing but IL max, 5.3 ampere. Over. See in the same question number B. This is question number A. Question number B. What it is asked? The value of L connected. You calculate what is the value of L connected. How to calculate value of L connected? To calculate value of L connected, then during T on, I will apply the formula during T on. During T on is, in this circuit, switch is on. Switch is on means VL plus V0 equal to VDC. Then what is VL on equal to? VL equal to V0 minus VDC. Correct? Sorry. VDC minus V0. How to define VL? L into delta L by T on. T on is nothing but a dt. That is VDC, how much it is given? 100 volts. V0 is how much it is given? 80 volts. L into delta L you calculated now. How much delta L you calculated? 5.3. D into T is equal to 20. Then from this we calculate what the value of inductance. Frequency, you know how much switching frequency it is given. Switching frequency is 10 kilohertz. In this problem, switching frequency is given is 10 kilohertz. See, this you substitute here. 20 into dt by 5.3. Then what is L equal? 20 into duty cycle is 0.6. Yeah, 1 by f you write 10 kilohertz. 10 kilohertz into 5.3. Then you simplify this one. We can get inductance equal to, from this we calculate inductance equal to 12 by 53 millihenry. This is 12 by 53 millihenry you can get. This is the second question. Clear? See the question number C based on this one. What it is asked? C question. You calculate critical value of inductance. Critical value of it may be discontinuous mode or continuous mode. The concept is in critical inductance is same. What is the critical value of inductance? R LC equal to R into 1 minus D by 2F. R is how much? 40. 1 minus 0.6 by 2 into frequency, how much it is given? 10 kilohertz. Then you solve this one. How much we can get? 0.8 millihenry you can get. 0.8 millihenry. 0.8 millihenry. Actual inductance is how much we are getting? 12 by 53 millihenry. If you calculate this one 12 by 53 less than 0.8 millihenry we can get now. That means L given, this is actual L given in the circuit is less than critical inductance now. You calculate 12 by 53, how much we can get? Less than 0.8 now. Less than 0.8 you can get. That is 12 by 50, that is 12 by 53 millihenry. 12 by 53 millihenry less than 0.8 millihenry. This is L less than LCR. Hence it is which mode? Discontinuous mode. Hence it is also proof. It is a discontinuous. Okay. Concentrate how to calculate IL max. Concentrate how to calculate inductance. Concentrate how to calculate critical inductance. Quick. Hold on. A DC to DC converter shown in figure is charging a battery bank whose voltage is constant at 150 volts. B1 is another battery bank whose voltage is at 50 volts. The ideal switch operates at switching frequency 5 kHz with a duty ratio 0.4. Once the circuit has attained steady state and assuming diode to be ideal, the power transfer from B1 to B2 will be dash. The power transfer from B1 to B2 will be dash. Okay, this is the given circuit. The inductance is how much it is given? 5 millihenry. The inductance is given as 5 millihenry. This is switch. And this is diode. This how much it is? 150 volts. And this how much it is? 50 volts. This 5 millihenry. This is B1. This is B2. Okay. The switch operated a duty cycle of 0.4. D equal to 0.4. Switching frequency, how much it is given? 5 kHz. Switching frequency is 5 kHz. Yes. You want to find power transferred from B1 to B2. How much power is transferred from B1 to B2? First, to analyze it, is it a continuous mode or discontinuous mode? There is data is given. Can you calculate what is V0? It is a which chopper? Which regulator? Boost regulator, because inductor is at the source side. Shall we write like this? V0 equal to VDC by 1 minus D. What is VDC given? 50. 50 by 1 minus D. 1 minus 0.4. Then what is V0? We get 50 by 0.6. 50 by 0.6 means how much we get? 500 by 6. 500 by 6 means how much we get? This here. You simplify this one. 3 times. 250 times. Then 250 by 3. 250 by 3 means how much you get? 8, 24, 3, 83.3 volts. This is V0 in which mode? Continuous mode. What is the given voltage? 150 volts. That is V0 in 83.3 volts is less than 150 volts. That is, this is V0 in continuous mode. This must be V0 in discontinuous mode. It is less than V0 in discontinuous mode is greater than V0 in continuous mode. Na? That means we are getting 150 volts means output voltage 150 volts we are getting means this circuit must be operated in which mode? Discontinuous mode. Then only we can get 150 volts. Yes, this is the circuit under discontinuous mode. Then you want to calculate what is the power transfer from B1 to B2. You calculate what is the power transfer from B1 to B2. Then how to calculate power transfer from B1 to B2? Then power transferred equal to power transferred from B1 to B2. Simple. Power transferred equal to VDC into IL. VDC into IL average or IL. VDC into, you calculate VDC into IL average. Then first, it is a discontinuous mode now. What is the formula in V0 discontinuous mode? This is dVDC by, this is VDC by beta into VDC by beta minus D. This is boost regulator now, beta into VDC by beta minus D. What is it is given? 150. 150 equal to beta into 50 by beta minus D is how much it is given duty cycle? 0.4. Then how much you get? Beta by beta minus 0.4 equal to 3. Okay, then shall you solve like this? 3 beta minus 1.2 equal to, this is beta. Then 2 beta equal to 1.2. Then what is beta? We can get 0.6. The value of beta equal to 0.6. But you want to find power transfer. If you want to find power transfer means you know VDC, but you want to find IL average. Then what is the average inductor current? What is the average inductor? Under discontinuous mode. Under discontinuous mode. What is the waveform we can get? Like this we are getting. This is which waveform? IL waveform. This is IL waveform. This is beta T. Beta T. Okay. This is T. From this again waveform will be started. This is IL waveform. Okay. Then this is, this peak value is how much? Delta IL. This peak value is delta IL. Okay. This. Then what is IL average? You tell me. IL average equal to half into this is beta T, total IL average. I want, this is the total average inductor current. Half into beta T into delta IL by T. Then CT cancels. Then IL average equal to half into beta into delta IL. That means you want to find IL average means first you know the what is the delta IL. Then how to calculate delta IL? Then go for during T on. During T on. Apply during T on. During T on means L into di by dt. During T on. Switch is on. Switch is on means diode is off. What is L into di by dt? VL equal to VDC. VL equal to VDC. What is VDC? 50 volts. Then L into delta IL by dt is nothing but a T on. During T on. This is 50. Then from this, how to calculate delta IL? Delta IL equal to 50 into T on by L. 50 into T on by L. How to write T on equal to dt? Can calculate like this. Here, you write like this. T on delta IL equal to T on. 50 into T on is D into T by L. How much L is given? 50 into duty cycle is how much? 0.4. L is how much? It is given 5 millihenry. Frequency you write 5 millihenry. T is written as 1 by F. If you write M by F means 5 kilohertz. 5 kilohertz. This is 10 power. This is cancelled. Then this is 25. This how much we can get? 0.8 ampere. Delta IL we can get 0.8 ampere. If delta IL is 0.8 amperes, you substitute here. What is IL average we get? IL average equal to 1 by 2 into 0.6 into 0.8. How much we can get? 2.4 ampere. IL average equal to 2.4 ampere. If IL average is equal to 2.4 ampere, what is the power transferred from the power transferred to the load? VDC is how much? VDC is 50 volts. 50 volts into what is IL average? 2.4. Then how much you get? 12 watts. This is the answer. Clear? First what I done? First I check this condition, continuous or discontinuous mode. It is a discontinuous mode. Then I calculated beta. Beta I am getting 0.6. Once I calculated beta, then I want to calculate IL average. IL average is equal to half beta into delta L. But I want delta L na, go for during T on. During T on means from this one delta L I calculated. Delta L what I am getting? That step I continued here. Delta L I am getting 0.8 ampere. You substitute delta L here. Beta you know 0.6. 2.4 ampere. What is the power transfer? Power transfer is nothing but VDC into IL average. 50 into IL average 2.12 watts we are getting. Clear? That you can. Important model.